Good morning, students. So today we're going to solve question 42 from GATE CSE 2025. The question states that consider the following four variable Boolean function in the SOP sum of product form. SOP basically means that the Boolean expressions are added together and the expressions themselves are composed of products of the variables, right? So this is the function, this is the Boolean function, and these are the four variables that are being fed inside of this function. Then its SOP format representation of this function is going to be made up of these kind of expressions, right? These kinds of expressions. And what are these numbers? These numbers represents nothing but the basically expression kind of if the expression were to be equal to a binary number, then its quantity is going to be equal to 12. Let me specify this with a good example. 12 is represented by this kind of expression. And why is that so? Because when there is no bar on top of a variable, right, B3 is the most significant bit over here because it is the leftmost. Because in a binary representation, in a number system representation, the leftmost number is the most significant bit. So over here, this B3 does not have a bar on top of it. So we're going to write 1 corresponding to it. Likewise, B2 does not have a bar on top of it. So we're going to write 1 corresponding to it. B1 and B0 have a bar on top of it. So we are going to write 0 in their place, right? So this is the number that we get. If we were to make this number, turn this binary number to decimal number, what we're going to get? 2 raised to the power of 3 plus 2 raised to the power of 2. So what are you going to get? 8 plus 4, that is 12, right? So that is why this 12 is written like this. This 12 in this summation, in this kind of expression, in this Boolean function representation, represent this expression. This is basic stuff, fundamental stuff that you must have already known, but I'm revising this so that you can have a clear concept, right? I'm assuming in this video that you already know how to use Kmap, but you have not used it in some while, so it is just a revision sort of thing. But if you're completely new to Kmap, then please go on YouTube and see a video regarding Kmap and get your concept straight first, and then come back, right? Because you cannot solve gate questions without having a fundamental concepts very crystal clear, right? So that once that part is done, let's read forward. So this is the Boolean function, and this is in sum of product form, where the value of the function is computed by considering this kind of expression as a 4-bit binary number. This is basic funda of Kmap. They're just giving it this expression funda, where B3 denotes the most significant bit and B0 denotes the least significant bit. Note that there are no don't carry terms. This is a extra information that they have given us. Don't carry is basically a cross that we put inside of the Kmap that is sometimes given, but here it is not given. So there is not going to be any crosses over here. So don't carry terms are not present. Okay, which one of the following? Only one. They are not multiple choice. This is not a multiple choice question. Only a single option is going to be correct. This is a 2-mark question. Okay, so which one of the following is the correct minimized Boolean expression for f? So f is the Boolean function and we have to minimize it. K-maps are used for minimization of Boolean expressions, right? This is the expression that has been given to us. Obviously, these numbers, these decimal numbers sometimes frighten the student if he has not studied this before, but they represent this kind of expression. All of these numbers can be represented like this. You can, if you were able to follow, right? They can be written like this. So it's a very big Boolean expression that when if you were to go and write all this, it's going to take a lot of time. So this is a very good way to express such big Boolean expressions, right? So we have to simplify it. Simplifying it direct, only expressing it is so much of a pain that we have invented a different kind of symbol to work with that. So why are you going to try to simplify it by first expanding it thoroughly, right? It does not make sense. So to simplify it, a format of Kmap was already invented, right? So this 0, one more thing, sometimes students are confused when you're going to solve this question by yourself. So you're going to be having this confusion regarding what two variables should I place on the downward side and what two variables should I place on the right side, on the top side, right? So let me tell you that on the downward side you must place the variables which are more significant, and more significant are the variables who come to the left side, right? So these two variables are placed over here and these two variables are placed over here, right? And the standard format follows that first both of them are going to be having a bar on top of it, then the less significant one is going to be remove the bar, then both of the bars are going to be removed, and then the less significant is going to have a bar and the more significant one is not going to have a bar. The same thing goes on for the downward variable expression also, right? Once we have done this, once we have drawn the k map, right, we can directly write ones at the places that are directed to us by this, right? So 0 is a 1, 2 is a 1, 4 and 8 is a 1, so 4 and 8 is a 1, 10 and 11. 10 and 11 are ones and 12 is also a 1. Very good. So these are all the ones that we're going to get, right? Now in K-maps, we can make groupings of the ones that are written by means of the number of terms inside of a grouping must be in the sequence of 2 raised to the power of n. What is the sequence 2 raised to the power of n? 1 is 2 when n is equals to 0. Then is 2, then is 4, then is 8, right? So over here, and the bigger the grouping, every single one, it is best to have every single one inside of a grouping because grouping simplifies the whole expression. This whole K-map stuff is being brought about to simplify, and to simplify we must do the grouping, and this is the format in which we can do the grouping, right? What is the biggest grouping that we can make for these 4 ones? We can directly put them inside of a group like this. Okay, for this particular one, we can group because there is no other what. So one more thing, every single corner of the key map is being grouped, so we can group them like this. These 4 ones can be grouped, right? So if this is the key map and all the corner ones are there, so we can group these 4 ones together because this is also grouping that is allowed inside of K map, so we can do that. And after all this single one is remaining. If we were to leave this 1 over here, this 1 corresponds to this 11 and this 11 corresponds to this expression, right? This expression is not simplified at all. So if you were to group this together with this particular one, so this is only 2 term grouping, so it is also grouping simplifies, right? So every single one has been grouped and hence the expression has been simplified significantly. Now we have to just express it in terms of SOP format, right? Okay, so let's write f is equals to your SOP format. So first of all, this if this is our K map, we are taking this particular grouping first, right? This one. Okay, so what when this grouping, all these ones are present, what all things are changing when you go across this grouping? These 2 terms are changing and all possible arrangements of these are being considered, right? For both of them not having bar, both of them having bar, single of them having bar, both possibilities for that also is being taken. So we can directly remove this part, and this part which remains constant is going to come over here. Okay, let's do that. So it is going to give us b1 bar, b naught bar plus, once this part is done, now let's focus on this kind of grouping, right? Let's focus on this grouping. So in this grouping, which part is changing? When you consider this one and this one, what part of it has changed? See, this B2 B2 bar is remaining the same, but the B3 bar, the bar is being changing, right? So we can remove this B3 and only B2 is going to come down. Okay, B2 is going to come down, B2 bar, but that is not the whole of it, because I know these two were to be considered and we are considering these two, but for this two, this part is remaining the same, right? This part is remaining the same, right? But when you consider these two, this part is also being also changing. So let's consider that. When you consider both of this, because it is a 2 raised to the power of 4 grouping, right? 2 raised to the power of 2 grouping, that is 4. So 2 of the variables, because n is equal to 2, 2 of these variables are going to be dropped when you do a 4 grouping, because when you did this grouping, 2 of the variables were removed and only 2 variables came down, right? Likewise over here also. So B2 bar we got. Now consider these two. What is changing? B1 bar is changing, right? B1 over here and then B1 bar over here. B2 B0 bar is remaining constant, so we can write B0 bar over here. So B0 bar remains over here, plus when you consider these two, this is the only grouping left after that. So in this part is now, mind you, over here it is a grouping of only 2 expressions, right? Only 2 terms, right? And for that 2 raised to the power of 1 is present. So now this time, from the original 4 terms that are present inside of this expression, only a single variable is going to be removed, right? Be mindful of that. Be mindful of that, because if you are mindful of that, then you can catch silly mistakes that you sometimes commit, right? When this is being considered, this part is not changing at all, so we can directly write this part down over here. B2 bar. In this, what is changing? B0 and B0 bar is present. So B0 is changing. So we can drop B0 and B1 is going to come over here. The changing part is dropped always, right? This is the expression that we got after the simplification given to us by the K-map method, right? I've simply followed the method of K-map simplification. You can follow any video on YouTube. If you have already done K-map, then I do hope that this particular video gave you a revision on that or you learned something. But if you have not done K-map at all, be mindful. This is a very important concept for GATE. Go through a video or two and then learn this concept, right? Which one of the options matched the answer that we got, right? B1 not, B1 bar, B not, B0 bar. So this part is same, okay. B2 bar, B0 bar, B2 bar, B0 bar. This part is also same. B1, B2 bar, B3. So this part is also same. So A option matches our expression, our simplified expression directly. So we got our answer for this question. It was a 2-mark question. It was a question that requires you practice in K-maps. Practice and confidence in your concept. Your concept must be strong, right? And I do hope that I made you learn something. And if you like the video, I will see you in the next video. Thank you.